Here we're going to look at an introduction to polynomials from a pre-calculus standpoint. So essentially, a polynomial in general is an equation where we have a variable that has a power. Now here we're looking at powers of larger values. So in general, our equation would look as follows, where our leading term would have a leading coefficient, so we call it a sub n, x to the n, where n represents the power or the degree of your equation. And you would continue down subtracting 1. We go in descending order all the way down till you get to your constant. Okay. So for example, I've got this mini table here where we can look at how to pick out information. Now the important information that we have is your degree, your leading term, and your leading coefficient. Now we have a couple different examples here. First and foremost is a constant. So this is a polynomial function, so a constant. And in that case, we're looking at, say for example, f of x equals 7. Well, the other way that we could essentially write that is that f of x equals x to the 0. And one of the ways we know that is because anything raised to the 0 power is 1. Therefore, this right here is your constant. A constant function has a degree of 0 because there's no x term, or as you can see with this one, my degree is 0. Therefore, the leading term and the leading coefficient are both the same value. And that would be 7. Now linear is the next one on the list. Linear says that we have an x value with a power of 1. So for example, if I had 3/4 x plus 1, my degree would be 1, because if you look at that x term, notice my power would be a 1, and we don't usually write that down. The leading term is the entire first term, so in this case it would be 3/4 x. Whereas the leading coefficient would be the leading number. So here this would be 3/4, and so on and so forth. Now when we talk about characteristics, we have things like the leading coefficient, the leading term, which we've talked about, your degree. We also are looking at continuous. Now polynomials have continuous motion. They are very smooth, and the line starts and smoothly goes all the way to the end. It doesn't stop or break. Okay. Now the other thing that we have is that your domain is all real numbers when we're dealing with our polynomials. Okay. Now with that, we have things called the leading term test. Now this is a test that is used to determine the end behavior of polynomial functions of any degree size. We use that leading term test especially when your degree gets rather large in order to help us determine characteristics of a large polynomial. So we're looking specifically at the end behavior. And what this end behavior is going to give us is it's going to give us the direction of the graph, and it's also going to allow us to focus in on what happens in the infinite spectrum. So we have two options, the even degree or the odd degree. Your even degree has two choices. Either both ending behavior points up or they both point down. In the one that points up, we call this to be positive. Positive meaning the tails point up. So when we're trying to explain the characteristics, we have that it's positive because the tails point up. Now the other one is considered to be negative. Negative meaning that your tails point down. Now the odd degree, if you remember, if you think about a cubic function, you have one tail points in one direction and one tail points in the other direction. So here we have two representatives of that. Now we are talking just about these end behaviors, so what happens here in the middle doesn't matter. In this left-hand side one, or the pink one, notice the right tail points up, the left tail points down. Okay, so what we call that is we call this one your positive. The way we describe it is that your tail points up on the positive x. So if we were to think about this being on an axis, you're pointing up more towards the positive side. This also means then that your tail points down on the negative side. We like to call this version increasing. That means the other, where my left-hand side pointing up and the right-hand side points down, this one is going to be your negative. It means the exact opposite. So in this case, what you'll notice is that your tail will point up on the negative x side, and your tail will point down on the positive x side. We like to call this one decreasing. Now, with this, it's important to notice or remember that you cannot make any conclusions about your middle behavior. We're only looking at the end behavior or the tails. Now, the reason this idea is important is because sometimes we are given an equation and we are asked to classify it or identify the characteristics, such in these examples. We want to determine a bunch of information. That information being the leading term and the leading coefficient, the degree, and the end behavior of the graph. Then we need to classify the function as its type. Okay, so here, first thing we're going to look at, or the first thing that we need to do, is we need to make sure that your polynomial is in descending order. So with that, if you look at this, we have x to the fourth, x to the third, x squared, x, and then the constant. So this already is in descending order. So now we need to have your leading term. We need to have your leading coefficient. We need to have your degree. And then we need to know the end behavior. And we need to know how to classify it. So first and foremost, let's take a look. Leading term, again, remember we are talking about this entire first piece. So my leading term is going to be 1/4 x to the fourth. That coefficient is going to be the number attached. So once you identify your leading term, your leading coefficient is the value attached, 1/4. The degree is going to be the degree of that x value, and so here my degree is 4. Now, if we take a look, we need to look at end behaviors. So we need to identify, are we even or are we odd? In this case, we are even. So notice my degree is 4, we're even. The other thing to note about it is that this is positive. So my end behavior here is positive, which means my tails point up. In terms of classifying, this is the power of 4. So there's two ways we can say that. We can call it a quartic, or we can call it power of 4. Alright, let's take a look at this next and last example. So here, again, the first thing we always want to do is make sure that we are in descending order. And if you look at this one, notice we aren't. I have first power, fourth power, fifth power, third power constant. So the first thing I need to do is I need to rewrite into descending order. So this is going to be f of x equals, so descending order says rearrange it. So 2/5 x to the 5th. Then we're going to go down minus 2x to the 4th plus x cubed. I don't have an x squared, but I have a negative 1/2 x and a positive 3. Once we rewrite everything into descending order, we can do the same thing we did before, which is identify all the pieces. So again, we need to know your leading term, your leading coefficient, your degree. Then we need to look at the end behavior, and lastly, classify it. So let's go ahead and do that. So my leading term again is that very first term, and this is why it's so important to rewrite things in descending order. If you look at the equation as original without writing it, we may identify the wrong term as being your leading term. So when we rewrite it in descending order, we are sure that we identify the proper information for classifying our polynomial. Now that being said, the leading coefficient again is that coefficient attached with your degree attached to the x value. Now in this case, my end behavior is going to be odd, and the reason it's odd is obviously my degree is odd, and if we look at this first term, it's positive. So here we are looking at a positive function where we have opposite directions. Lastly, we have to classify it. So there's a couple ways we can do it. We can call this one a quintic, or we call it the 5th power, or power of 5. And that's really all there is to it in terms of the beginnings of polynomials. So again, as long as you remember, write your polynomial in descending order, and then identify everything that you know about that first term in terms of what the term is, the coefficient, the degree, and your end behavior. You are well on your way to being able to classify, graph, and even work with these upper level polynomials. So if you have any questions, please let me know. If you have any other examples or any confusion about classifying and working with these higher level polynomials, let me know that too. I would be more than happy to work out additional examples. Otherwise, I do hope you had as much fun as I did, and I look forward to chatting with you next time.